Hi friends, how are you? Welcome again to our YouTube channel Engineers World. So today is the second lecture of RCC. In the previous lecture we studied some basic concepts of RCC. So in today's lecture also we will continue the same, that is basic concepts. So starting with the cross section of a reinforced cement concrete beam. If this is the cross section, today I'll show you all the details of an RCC beam, cross section of an RCC beam. See, this is a neutral axis. This is compression zone. And below neutral axis is tension zone. Now, if I make the reinforcements, then we also have a different type of reinforcement, and these are called as tie-ups. These are basically the shear reinforcements, and these are anchor bars. See, these tie-ups also always make an angle of 135 degree with the horizontal. The reason is that during an earthquake, when the structure gets disturbed, so this reinforcement doesn't get open. If we use any other orientation, then it will be opened. So this is our shear reinforcement, or tie-ups you can say. These are meant for shear reinforcement. They help in preventing shear, as well as they'll help in holding together all the bars so that these bars do not get dislocated. This is our tension steel. Now see, today I'll tell you one more definition or one more term. See, in last lecture we studied about effective cover, that is distance of CG of reinforcement to the bottommost tensile tension face. So let I denote it by DC. Now here comes one more, D effective, DEFF. There is one more term called as clear cover. So this is the clear cover. So what is the difference between effective cover and clear cover? See, the effective cover is the distance between CG of reinforcement to the bottom face of to the tension face. But clear cover is from the bottom of the reinforcement, that is tie-ups, to the tension face. So this is the difference between clear cover and effective cover. These are anchor bars. So this is the detailed cross section of a reinforced, you can say singly reinforced RCC beam. Now, in last lecture I also discussed about the various exposure conditions. Now I'll today again continue the same topic regarding exposure conditions. See, if here I write the exposure condition, here I'll write the minimum grade of concrete, and the third column will be minimum clear cover for reinforcement. I already explained you what are the various exposure conditions. There are 5 exposure conditions: mild, moderate, severe, very severe and extreme. First one is mild. Second is moderate. Third one is severe. Fourth one is very severe. And fifth one is extreme. I also told you the minimum grade of concrete for each exposure condition. For mild it was M20. For moderate it is M25. For severe it is M30. These are minimum grades of concrete corresponding to these exposure conditions. For very severe it is M35, and for extreme condition it is M40, that is minimum grade. Now we also have minimum clear cover for reinforcement as per the exposure conditions. So for mild exposure condition, minimum cover is 20 mm. This should be remembered. For moderate it is 30 mm. For severe condition it is 45 mm. For very severe it is 50 mm. And for extreme condition it is 75 mm. So these were the exposure conditions and the minimum grades and minimum clear covers for reinforcement. Now we will move on to next topic, that is again regarding to these exposure conditions. So the next topic is examples of exposure conditions. See, there are various examples which they directly ask in the exams like GATE, ESE, SSC, JEE. So it is an important topic. Star mark. So the first condition we will take is rain. So in case of rain, there are 3 conditions. First condition is not exposed to rain. So in this case, if the structure is not exposed to rain, or the concrete or RCC is not exposed to rain, the exposure condition will be mild. Remember. Second case is if the structure is exposed to rain. So if a structure is exposed to rain, the condition or exposure condition will be moderate. And in the category of rain, the subcategory is, third subcategory is exposed to severe rain. So if a structure is exposed to severe rain, the exposure condition will be severe. So these were the exposure conditions in case of rain. Now second is in case of concrete in normal water. So under this we have 2 conditions. First one is completely inside water. So if a structure is completely inside water, then the exposure condition will be moderate. Under this, the second subcategory is alternate wetting and drying. So if a structure is exposed to alternate wetting and drying, then the exposure condition will be severe. So this was in case of concrete in normal water. So our next category is sea coast area. I'll make it here. So our next condition is sea coast area. So under this, there are a lot of subcategories. If a structure is not exposed to saturated air in coastal area, structure not exposed to saturated air, in coastal area. So in this case, the exposure condition will be moderate. Second subcategory is exposed to coastal area. So in this case, if a structure is exposed to coastal area, then the exposure condition will be severe. Third subcategory is completely inside seawater. So if a structure is completely inside seawater, the exposure condition will be said as severe. And fourth condition is seawater spray. If a structure is subjected to seawater spray, then the exposure condition will be called as very severe. Remember. And the last subcategory here is tidal zone. If a structure is in tidal zone, so if a structure is in tidal zone, the exposure condition will be extreme. So you must be remembering all these categories and corresponding exposure conditions, because these are directly asked in the exams like GATE, ESE, SSC, JEE, and maybe in iPATE also. So this is all about the exposure conditions and their examples, the minimum clear cover for different minimum grades for different exposure conditions. So next topic is behavior of concrete under uniaxial compression. So what is this? See, strength of concrete is determined by the compressive strength test on a standard 150 mm concrete cube in a compression testing machine. So we usually cast cubes whose dimensions are 150 by 150 by 150. So these concrete cubes are cast and we perform compressive strength test on these cubes on compression testing machine as per IS 516 1959. So this is the code for compressive strength test. These specimens are generally treated after 28 days of casting and continuous curing. The loading in the compression testing machine is usually strain controlled. Remember, loading is strain controlled. Loading is strain controlled and the load is generally applied at a uniform strain rate of 0.001 mm per minute. So this is the strain rate and it is to uniform. So the maximum stress attained in this loading process is called as cube strength of concrete. The maximum stress attained will be called as cube strength. Now see, in some countries instead of casting 150 mm by 150 mm cubes, they cast standard cylinders of height to diameter ratio of 2. That is 150 mm diameter and 300 mm height. See, in countries like USA, instead of casting cubes, they cast cylinders of height 300 mm and dia 150 mm. Now there must be some difference in calculations of strength in cube as well as cylinder. So the difference is that cylinder strength comes out to be lower than the cube strength of concrete. So strength in case of cube comes out to be more than that of cylinder. So how much is that? The cube strength is nearly 1.25 times the cylinder strength. Cube strength is approximately 1.25 times cylinder strength. So you must remember all these values. So this was all about behavior of concrete under uniaxial compression. So our next topic is behavior of concrete in tension. We studied about the behavior of concrete in compression. Now we will focus on tension. See, we know concrete is quite weak in tension and is not supposed to and also not designed to take any direct tension. But tensile stresses occur in concrete due to flexure, shear, shrinkage and temperature stresses. See, pure shear causes tension on diagonal planes, for which sufficient knowledge of direct tensile strength of concrete is important. So we can say that direct tensile strength of concrete is about direct tensile strength of concrete is about 7 to 15% of compressive strength of concrete. Compressive strength. Of concrete. This figure should be remembered. Now, it is very difficult to have direct tension test on concrete as it requires pure axial tensile stress free from any secondary stresses and misalignment in the tension testing machine. Thus, we perform indirect tension tests using flexure test or split cylinder test. So before studying these tests, there is a term called as modulus of rupture of concrete. So what is modulus of rupture? It is denoted by F subscript CR. So what is this modulus of rupture? See, when we perform the flexure test, a standard simply supported plain concrete beam of square or rectangular section is used, which is subjected to 3-point load until failure. See, we usually cast this beam and it is subjected to 3-point load test, 3-point or 4-point bend test, 3-point or 4-point bend test. So for a linear stress distribution across the section, the theoretical maximum tensile stress which is developed in the extreme fiber is called as modulus of rupture. So this modulus of rupture denoted by FCR is simply given as M by Z, where M is the bending moment that causes failure and Z is the section modulus. But remember, the actual stress distribution across the section is not linear. So what happens, or IS 456 2000 recommends the use of the formula for modulus of rupture of concrete, that is FCR is equal to 0.7 times root FCK, where FCK is the characteristic strength of concrete. So remember, this is as per IS 456, where the units are in MPa or Newton per mm square. So this is all about modulus of rupture. By explaining modulus of rupture, I have also explained you the flexure test that is performed on PCC beam. It may be rectangular and subjected to a single point load or 2-point loads. Now, second one is split tensile strength of concrete. So what is split tensile strength? So our next topic is split tensile strength. Strength of concrete. So what happens in split tensile test? Cylinder splitting test is performed, which gives more uniform results. So in this test, a standard plain concrete cylinder, as used in compression test, is loaded on its sides along the diameter, just like this. For example, this is a cylinder. So along the sides it is loaded like this. Let it be a length of cylinder. This be the diameter of cylinder. So this standard plain concrete cylinder is loaded on its sides. So failure occurs by splitting of the cylinder along the plane of loading. Failure occurs along the plane of loading by the splitting of cylinder. So this type of loading produces a uniform tensile stress across the plane of loading. The splitting tensile strength, denoted by FCT, is then given by the formula 2P upon pi dl, where P is the maximum load applied at failure, D be the diameter of the cylinder specimen, and L is the length of the cylinder specimen. So this was all about behavior of concrete in tension. First one was flexure test and second one was split tensile test. So that's all about today's lecture. Hope you would have enjoyed and liked today's lecture. So please like and subscribe our channel.